This is Geometry, Lesson 723. We're going to do some proofs with congruent triangles. All right, so first we're going to talk about rectangles, and we're going to prove that rectangles have parallel sides, which makes them a parallelogram. If we can prove that it's a parallelogram, then we know a lot of properties about the rectangle based on the fact that it is a parallelogram. All right, so we're going to redraw the rectangle that's up there. All right, and a rectangle is defined as a quadrilateral that has 4 right angles. All right, so a square is also a quadrilateral that has 4 right angles, but it also has equal sides. So all the properties that the rectangle has, the square also has. And so we're going to prove, and it's going to be a really quick proof, that opposite sides are parallel. All right, so I know that B and C are same side interior angles, and I know that they're both 90 degrees, and 90 plus 90 is 180. We have a theorem that says if same side interior angles are 180 degrees, then the sides are parallel, then the lines are parallel. All right, so I'm just going to write all that information down. So angle B equals 90 degrees, and angle C equals 90 degrees. So then angle B plus angle C, and I should be putting an M in front because it's really the measure of those angles, equals 180 degrees. And I could put, my reason is like the addition property and substitution. All right, so now we're going to say angle B and angle C are same side interior. Since the same side interior angles are supplementary, remember supplementary means they add up to 180, then AB is parallel to DC. Okay, that's what we would call like a paragraph proof, where we don't put anything in bubbles. We give all of our information just in sentences. Sometimes I like that proof a little bit better because you can go in any order that you want as long as you're explaining along the way. All right, so then we know that AB is parallel to DC, and then the same thing, angle A and angle B would also be same side interior that add up to 180. We also know that AD is parallel to BC with that same reasoning. All right, so a rectangle is a parallelogram, which means opposite sides are congruent, diagonals are congruent, and diagonals bisect each other. All right, so in number 73, we're going to take a break from writing our proofs and find the value of x based on if the triangles are congruent or not. All right, so in part A, the triangles do look congruent, and we know this because this side, 8, is equal on both, and if this is a straight line and that angle is 90 degrees, the other angle should also be 90 degrees. 90 plus 90 is 180. And then these sides are equal to each other because they're marked. So we know that these two triangles are congruent by side angle side. and that means that we can find x. All right, and we're going to use Pythagorean theorem. So a squared plus b squared equals c squared. C is always the hypotenuse. A and B are the base and height, or the legs of the right triangle. So I'm going to set this up as x squared plus 8 squared equals 10 squared. So I always remember that is the hypotenuse. A lot of students just write the two numbers and add them together, but that is not always correct. So after this, we just want to simplify. 8 squared is 64. 10 squared is 100. And get x squared by itself, so we're going to subtract 64 on both sides. Come up here because I'm running out of room. So x squared equals 36. Hopefully you know 6 squared equals 36, so x equals 6. If you did not know that off the top of your head, you can always get rid of a square by square rooting. Remember, that's the inverse of that. We don't, usually when we square root, we have positive and negative answer, but since we're talking about side lengths, we know that it has to be a positive 6. All right. And so next, in part B, we have these two triangles right here. And so I know that the shared side is equal right here. So we have an angle side, but we just need another angle. Since these two lines, AB is parallel to DC, that means the alternate interior angles are also congruent. So these two triangles are congruent by angle, side angle. Had those two sides not been marked parallel, then there would not be enough information. All right, and this one's easy. We don't have to do any calculations. We just know that corresponding sides are congruent. We know that AD is corresponding to BC. So that means that x equals 10. And next we head to part C. So these two triangles are within a rectangle, so there's a lot of different ways that we can prove this congruent. Obviously 11 is equal to 11. We could do this two different ways. We know that opposite sides are parallel, so AB is equal to DC. We know that because it's a rectangle. So we could use side angle side using the right angle, angle B and angle D. So I'll just put side angle side. We could have also used side, 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 side. Forgot how many sides I said. And we could have also used angle side angle, because we know that alternate interior angles here and here are congruent. All right, and now we can solve for x. So I'm going to look at just this right triangle right here. I know that this angle is 35 degrees, and so I'm going to use trig to find x. All right, so we're going to use SOHCA or TOA. I'm going to write that up here. Sine, cosine, or tangent. Remember, that's our memory device to figure out which one we'll use. So we're going to label the sides first. So the side opposite of 35 is 11. This is the hypotenuse right here, and which means x is the adjacent. Since we want to find the adjacent and we're given the opposite, OA, we're going to use tangent. So I'm going to set this up, tangent of the angle, which is 35, equals opposite over adjacent. Remember, it goes in order. That's why the memory device is really nice to use. 11 opposite over adjacent x. All right, so from here, we are going to put tan 35 in our calculator, and I got about 0.7. After that, our next step is cross multiplying. So I'm going to put this over 1 and cross multiply these numbers. So this is 0.7x equals 11. Divide 0.7 on both sides. And we would get x equals, let me put this in my calculator real quick. 11 divided by 0.7 is about 15.7. Okay. All right. And then moving on to part D. Let's look at this. So we have two angles that are equal, angle, angle. We could use angle, angle, side, or angle, side, angle, but we don't have any markings and we don't have any sides that are overlapping each other like we do in A, that middle, C, that diagonal, and B, that other diagonal. So this one is just like angle, angle, and that's for similarity, not for congruent. So this one doesn't have enough information. We cannot solve for x. Okay, so we don't have enough information to know if it is a similar triangle or a congruent triangle.